So in our last video, we looked at permanent magnets. Now in this video, we'll look at electromagnets. So let's start by looking at this blue wire. Okay, so this blue wire has got a current flowing through it. Now, you might be asking yourself, what are those orange circles? Well, a current carrying wire will actually form a magnetic field around it. And it will be in concentric circles around the wire, like this. Okay, so that's what the field lines will look like. Now, how can I tell the direction of the magnetic field? Well, I can use the right hand grip rule or the right hand thumb rule. So what I've got here is a right hand doing a thumbs up. If I point the thumb in the direction of the current, then the fingers will point in the direction of the field. Okay, so they sort of go, in this case they go anti-clockwise around. Okay, so I can put my arrows anti-clockwise around like this. Okay, so there we go. So a wire carrying a current will produce a magnetic field. You can figure out the direction of the magnetic field by using the right hand grip rule. Okay, just point your thumb in the direction of the current, and then the direction of the field will be in concentric circles pointing in the direction of your fingers. Okay, just make sure you use your right hand for this. Okay, so what have we got here? So we've got, I've got the blue wire here, and I've wrapped the blue wire around in circles. So I've just got a big coil. Okay, now if you did the right hand grip rule for every single part of this wire, this current carrying wire, then you'd actually get a net magnetic field that looks a little bit like this. Okay, it sort of looks like the magnetic field of a bar magnet, except we've got this middle bit as well through the coils where there's a very, very strong uniform magnetic field. Okay, the lines, the magnetic field lines are very close together, so you can tell that they're very strong. Now this is called a solenoid. Now this solenoid is going to produce a magnetic field. If I took an iron core, what's going to happen? What's going to happen to the iron core if I put it inside the magnetic field? So remember from last video, if I take an iron core and I put it inside a magnetic field, it will become a magnet itself. It will become an induced magnet. So if I took this iron core and I put it straight through the middle of this coil, then I've made myself an induced magnet. Okay, so you see what I've done. I've got a north pole here and a south pole here. Okay, so there's my induced magnet. This has now become an electromagnet. If I then turn off the current, just notice this current line is pointing in the wrong direction. If I then turn off this current here, then I stop the electricity from flowing, then the magnetic field will disappear. Yeah. What's going to happen then to the induced magnet? Well, remember, when it leaves a magnetic field, it quickly loses its magnetism. Yeah. So this is called an electromagnet. Okay. If I turn the current on, if I allow the current to flow, a magnetic field is going to be generated, and that's going to cause the iron core to become a magnet, an induced magnet. Okay, so I can use it just like a normal magnet. If I then turn off the current, then it will quickly lose its magnetism, and it will become just a normal lump of iron again. Okay, so it's a magnet that I can turn on and off again, basically. This has got loads of uses. I think most people will probably be aware of the electromagnets they use in scrapyards to pick things up. So you've got a gigantic electromagnet that you can turn on, you can pick up a car with it, and then when you want to drop the car, you can just turn off the electromagnet and it will drop. Yeah, so there's all sorts of uses for electromagnets, but this is how they work. Just a current travelling around a coil with an iron core in the middle. Okay. Right, I will see you in the next video.